The Boolean algebra is online logical operation, but in this course is for switching networks. We represent the inputs and outputs of a switching network. For example, x and y can take two different values, such 1 or 0, 1 is for true and 0 is for false, but in some cases 0 can be true.
Basic operations. In a logic system, like unions in a structure, they has a purpose, provides logic construction, functionality, and strength. Our basic operations are a buffer, not, and or. And the last three of them provides some characteristic for our logic system. What a buffer is. One of our basic operation is the buffer. It has one function and one output, but the function has the same result as the output. If you have an input of 1, the output will be 1 and is always the same variable in and the output.
Operation is represented with a point and is referred to as a logical multiplication. The AND gives us true when all the inputs of variables are true.
Basic operation OR. OR is an operation that has two variables, variable A and variable B, but has a cross on them. Whenever of these, A or B, has a 1 or are true, the result will be true or 1. But when both A and B has a 0, the output will be 0. The same case is when A and B has 1, the output will be 1.
The function not is represented with a positive or with a line above the variable and deny the input of the variable. For example, if you have 0 in the input, you will have 1 in the output.
Other Boolean law is the commutative theorem. This is when the variable A is in series with the variable B. As the result, it could be the variable B in series with the variable A, like two switches in series.
The associative theorem allows the removal of brackets from an expression and regrouping of the variables.
Other Boolean law is the distributive law. When you have a variable A multiplied variable B plus variable C, as a result of this, you will have variable A times B plus variable A times C. It only applies for the OR basic operation. When you have an AND, like you have an A plus B times C, it will be equals a POS. It will be A plus B times A plus C. That is the distributive law for AND.
The annulment theorem says if you have A and 0, you will put 0 in the output. Or if you have A or
Identity law. Other Boolean law is the identity. When you have an a as a variable in a OR, you have OR plus 0. Then the result will be a. This because the O cross a, it will not affect the variable a. When variable O is ANDed, you have an a times 1. Then, as a 1 is true, it only times the a, and the result will be a.
The debunking law says an input that is AND or OR with itself it equals that to that input.
Double negation law. This Boolean law, you could be a variable and then invert twice. As a result, you have the equal as the original term. For example, you have a with double negation, it will be a. Then you have the same result in both sides. It's like the buffer that you have a function with a, as a result you have a add.
De Morgan's theorem gives the same equivalence in backward, that inverting the output of any gate results in the same function as a positive type of gate, MPC or.
Absorptive law. This Boolean law enables the reduction of two variables. For example, you have a dominant a in a OR. You have a plus a times b. The result will be a, because when the letter b affects the letter a that is multiplied, you have also a letter a alone. Then the result will be a. In an AND absorption law, you have the a multiplying a plus b. Then, when letter a multiply the a, it will be the same result. But if letter a multiply a b, imagine that is a 0, you will have a letter a also, and then the result will be a.
The truth table is a diagram that shows the inputs and outputs of our one expression volume. If you want to know how numbers zeros or one you will need to do a sum operation. For example, if you have two variables, you will do 2 elevated to the number of variables you will have. In this case, we have only 2 variables, and also we have 4 numbers, 2 zeros, 1 1, 2 1 for each variable. In the first column you will put a, in the second column you will put b, and in the third column I will deny the first variables, in this case is a. If I have 0 in this column, we have 1, and the next column I will do the function. In the functions tell me not a or b. If we have not a is in the first is 1, if b is 0 or is 1. 1 or 1 is 1, 0 or 0 is 0, and 1 or 0 is 1. These two tables depends of all the variables that we have.
SOP, sum of products. In a truth table that has lots of zeros and only few true or ones, and you don't understand which function will represent that truth table, you can use the SOP method. The SOP method will help you to find a function that provides the truth or that outputs. SOP use different AND functions. Then they will be added one with other. Imagine you have three variables A, B, and C, and one of them is 0 and the other are 1, and the output is 1. You will change the variable C. Imagine you have a 0 and you need to have a 1. Then that 0 will be changed if you put your variable C as a C naught. Then imagine that you already have the other function, that is a B naught, and C naught. Then you will be addition that two functions. That is a SOP. In a truth table that you don't understand and you have lots of true but only few zero outputs or false outputs, you can use the method POS. That means product of sums. Like SOP, that is sum of products. Now you will be time a sum by other sum or other sum. It depends on the number of zeros. Imagine you have 8 outputs and you don't understand why you have only 2 zero outputs, and you can identify the function that provides you how the truth table it works. Then you can use POS. You only select the zeros, and in the zeros you create a function, an OR function. Imagine you have 3 variables. You select the A, the B, or C, and if you have 1, you need to change it for a 0. Then that variable will be not. Imagine you have a 1, a 0, and a 0, and the result is 0. The variable A, that is the first, is 1. You change it for 0 with a naught. Then imagine that you have the other output as A plus B plus C naught. Then that two functions will be multiplied together.